Hello everyone, this is R. Suresh Kumar, working as Assistant Professor in the Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the previous sessions, I explained about the evaporation and the different type of the evaporations and types of the evapo pans, just like ISA pan, Indian Standard pan, and also sunken pan, and also uh, floating pan. Like that, these are all types of the pans and its dimensions and its uses and where it can be applicable and can be discussed in the previous class in that detail. And again, here you have to measurement of in the measurement of evaporation, the pan evaporation measurements is also covered in the previous sessions. So now we have to go and quickly move on to the topic of the empirical methods and analytical methods. Actually, this is the second part of the evaporation, and the first part is already explained in the previous class as the evaporation method. Different type of the pans can be used for the evaporation, and this can be now we have to go into the moving topic of empirical methods by analytical methods. Let us see what is the empirical methods and where the analytical methods can be seen. Let us see. Here in the empirical equations, most probably available empirical equations are estimated like lake evaporations or Dalton type equation can be generally we have to be used. And next EL is equal to the formula can be explained. EL is equal to K into F of U into EW minus A. This is the wonderful equation to measure the lake evaporation of the Daltons. So EL here, let us explain the one by one. EL is equal to lake evaporation mm per day and EW is equal to saturated vapor pressure at the water surface and the temperature mm or mercury. Next, EA. What is meant by EA? Here, actual vapor pressure of the overlying air at the specified height of mm of the mercury can be used. Next, F of U. In the wind speed of the correlation function can be identified by F of U. Here, K is equal to coefficient and EA is the measurement of the same height at which the wind speed U is ensured. So that is the empirical equation, the first Dalton equation general form. Next one, Mayer's equation. In the Mayer's equation, what we are explaining, EL is equal to here, EL is equal to Km into EW EA 1 plus U9 by 16. That is the another formula of empirical formula to find the evaporation. So EL is equal to lake evaporation mm per day and EW is equal to saturated water vapor pressure at the water surface, temperature mm of mercury. So next EA is actually vapor pressure of the overlying at the specified height of mm of mercury. Next U9. What is meant by U9 is equal to monthly mean wind velocity kilometers per hour at the height of the 9 meters above the ground. The next one is Km, the coefficient of accounting for the other factors. So it can be denoted 0.36 for large deep waters and 0.5 for the small shallow lakes. Next one is ROVERS. In the ROVERS formula is also account the presentation addition of the wind speed effect. In this formula you have to explain the wind how the wind speed can be used for this one, and 0.771 and 1.465 minus 0.00732 P of A into 0.44 plus 0.0733 U naught AW minus EA. So PA is equal to mean barometric pressure mm of the mercury. So they are showing, and U naught is equal to mean wind velocity in kilometers at the ground level, and taken as the wind velocity is as generally take it as 0.6 height, and the ground of the EL, EW and EAR as mentioned is earlier whatever we discussed in the first one is Dalton's equation. Next wind vessel, how the wind velocity can be affected for the evaporation in the empirical formulas. Let us see that one in the part of the atmosphere of the height of the above 500 meters and above the ground level, wind velocity will be 1/7 of the power of the law. U of h is equal to c into h to the power of 1/7. So this is the formula to find the wind velocity, and u here UH is equal to wind velocity in kilometers per hour at the height in meters above the ground level, where c is equal to constant. So this is the wind velocity can be taken for the by using the empirical formula by calculating the evaporation. Next methods can be, we have to move. Up to this we have to discuss about the empirical formulas, and the previous one we have to discuss the evaporation pans. That is can be physically what the evaporation can be calculated. But again, the another one empirical formulas we have to be find out different type of the evaporations by applying the different type of the methods can be used for calculating the evaporation. So that is the one of the technique can be used for the evaporation by using the next energy budget method. Next, analytical methods. In the analytical methods, the first one is water budget method, energy budget method, mass transfer method. These are three types of methods by the analytical methods. Next, water budget method. So here they also one of the equation to calculation of the water budget equation. So V is equal to S delta S, EL delta S TL. P is equal to daily precipitation and daily groundwater flow and daily surface from the lake and daily groundwater flow and daily lake evaporation and increase in the lake stroke in the day and daily transpiration losses. All the quantities are expressed in the units of volume of the depth. So that is the units of the depth. So by this one we have to apply some of the P, Vs, Va and delta S can be measured and can be also estimated by denoted by the velocities. The unit time of the large estimation of the evaporations can be more accurate. Simplest all the methods but the least of the reliable. Next, energy budget method. The second one is energy budget. So it involves the application of the law of conservation of the energy and the energy available in the energy determination by considering of the incoming energy and outgoing energy and the energy stored on certain water body over the known time interval is energy water budget method. So next point is the estimation of the evaporation from the lake by this method has been found to give the satisfactory results with error of the other of 55% when applied to periods of the less than a week. Here we have to understand here what happens in the third point. So estimation of the evaporation from the lake by this method has been found and give the satisfactory results by applying this method, and with error of the order of 5% when applied the period of less than a week. So the previous what the energy available in the evaporation by considering the incoming energy and outgoing energy and energy which is stored on certain duration of the period of the time interval. So the previous one. So from this one in the energy budget method we will find out the evaporation. Next, there is the one of the formula can be have to apply for the energy budget method. Here energy budget method is equal to HA plus HE plus HG plus HS plus HI. So these are the formula to find out the energy budget method. In the energy budget method, HN is equal to net energy, heat energy, and HB is equal to back or radiational from the water body, and HA is equal to sensible heat transfer, and HS is equal to heat stored in the water body, and heat energy by use of the evaporation, and net heat conducted out of the system by water flow. So this is the denotions denoted by the above the formula for calculating the energy budget method. Next, energy balance of the body. any energy balance of in the water body, how the energy can be balanced. In the water bodies, we have to, this energy is balanced per day. All energy terms of the calories or square per day can be find out. Next, in all time of the shots, HES and HCI can be neglected in any of the negligible small. All terms can the HEA either be measured or evaporated directly. It can be estimated by the Bowen's ratio. Let us see in the diagram. You can understand easily by HEA evaporation and HB for this back radiations, and it can be also used from the solar radiations is there, and heat flux which is inside the pond or the water body. Next, advection HCI is also of the water body can be stored. Hg is equal to HCI already given, heat energy in the heat stored in that one, and I minus r by applying by derivating of this above of the water body, we will find out the one of the formula for calculating of the energy balance in the water body. So energy balance in the water body can be beta B is equal to HA by P into L into EL, that is equal to 6.1 into 10 to the power minus 4 into PA into TW minus TA by EW minus EA. So by this formula we have to find the evaporation also, and this evaporation, let us see the notations are given in the calculation of energy balance in the water body by applying in the equation mentioned. So the here PA is equal to atmospheric pressure or mm of mercury, and EW is equal to saturated vapor pressure of the mercury, and EA actual vapor pressure of the air of the mercury, and TW is equal to temperature of the water surface in 0 degrees centigrade, and temperature TA is equal to temperature of the air in 0 degrees centigrade. TW is equal to temperature of the water surface 0 degrees centigrade, and TA is equal to temperature of the air in 0 degrees centigrade. That is the difference between these. Temperature of the water surface, temperature in the air. That is the TW and TA. And another one is EA and EW. And EA is equal to actual vapor pressure in air and saturated vapor pressure. So these are the two can be given. And PA is equal to atmospheric pressure of the mercury. So from these notations, we will find out the value of the energy. What are the energy balance in the water body can be find out by using the derivation, by applying the equation also. Next, evaporation control measures. Evaporation control measures. How to control the evaporation? So in the previously we have to apply different type of the methods by calculating the evaporation by whatever it is the evaporopans, and by analytical methods, by using the empirical methods. There are three types of methods are just you are using by using this one, you have to find out the evaporation of the different sources of the methods can be applied for calculating the evaporation. But is there any techniques to find out the evaporation control? So let us discuss in this one all those factors which are either responsible for the evaporation. For 10% of the evaporation is restricted, we control the evaporation from the water bodies. These methods can be also be discussed under the following of the two main schedules. Next, first one is very important, reduce the surface area. Reduce the surface area. In the reduced surface area means lot of area, the evaporation will be also increases. Automatically the evaporation and due to the effect of the temperature and whatever the evaporation can be also increases. So like that the area increases, automatically the evaporation will be also be increases. It is the increases of the evaporation and also surface area will be directly proportional. It means it increases, automatically evaporation is also increased. What we will do? For this one, we will bifurcate into the small ponds. So let us see how can you someone measures to reduce the surface area. Suggestions can be given such as first the constructing the reservoirs with the minimum ratio of the area storage. It means the storage capacity will be reduced, but requirement of the storage capacity will be necessarily. But instead of 1, we can reduce the bifurcate into 4 to 5 can be bifurcated for the reducing the surface area on certain location. That is the first point. Then the next point is storing of the water below the ground level. Is a better below the ground means, so in the below the ground, especially the evaporation losses will be less when compared to the above the groundwater storage. So that's why better to store the water in the below the groundwater storage of the water. Next, third point is storing of the water in one large reservoir instead of several small reservoirs. So that I told that instead of big one, the storage of the reservoirs can be make it as small one. So that is the third technique. And fourth one is selecting the proper reservoir sites. So in the proper reservoir sites means the area we have to be construct the reservoirs will be the minimizing the losses by applying the different type of the sources can be whatever the physiological factors or environmental factors, whatever it is. The selection of the site for this one can be taking care for the storage of the water by reducing the evaporation. Next one is streaming the channels, that reducing the modeling of the surface area of the water. That is the one of the point to reduce the surface area. The first technique is surface the reduce area, and the surface reduce area, some of the points are, the denotations are given for reducing the surface area. Next one is altitude of the reservoir sites. And altitudes of the reservoir sites means here that the construction of the reservoir is always above the some of the mountains or gorges of the higher altitude of the preferable. In the higher altitude preferable means what happens in that construction of the high altitude. Let us see. The water surface of the temperature will low in the lowest vicinity. So that's why we have to be construct to prefer the above the ground level or mountain areas above the to construct the storage of the water. Therefore, the saturated difficult and will be less. The evaporation rate from the water body will be also be less. Next, this will reduce the total evaporation loss of the reservoir. Secondly, the surroundings of the high mountains acts as the wind barriers. That is the very important to reducing of the evaporation. The next point is this reduces the rate of evaporation, and eventually the total water loss due to evaporation is reduced by the evaporation losses. That is the one of the point to reduce the evaporation of the altitudes of the reservoirs. This is the one of the second technique. We have to construct the storage capacity of the reservoirs. Next point, third is suppression of the by surface films. It means the certain chemicals can be used by the polar components such as evaporation as well as suppressors and substance and process the molecules which has been effectively water at one end. When the chemical substances is contact with water, the molecules can be tends to be itself the one end and the water other end is joining to the surface of the water. So it means the one end to the water can be to capacity and film can be used, and other one is projecting of the surface of the water can be reflected. Next, the thickness of this film is less than the microcentimeters. Is invisible color associated with oil films, and next it is the oil films. Next it is the presence in the surface water characterized by the absence of the tiny wavelets and has been supplied by this film. So generally, this film can be penetrated and the droplets with the close again after being this broken. The flexibility of the moves of the motion of the water surface does not easily break you thick films of the oil. Hexagonal is a hexagonal type of can be spread over the entire the spread area. It can be spread like that in the top of the but whenever droplets of the appear toxicity, droplets are comes in the rain of the droplets, whatever comes, it can be spread and can be allowed, and again it can be closed on that certain area. So this is also one of the technique can be used uh, for the reducing the for the evaporation, for reducing the, this is one of the best technique to it is this what we are using the cetyl alcohol can be used for the chemicals, and cetyl alcohol the whatever you are using the chemicals by applying the top of the layers, it cannot be affected in the for any of the animals, and the plants cannot be disturbed and cannot be damaged for this environment. That is the very important for the fishes and any other which is also living organisms inside the water will not be affected by toxicity of the which are chemical for using the reducing the evaporation. Next, and also this one of the technique can be used for the surface of the uh, uh, type of the small lightweight bricks can be used in the spread over the entire area. So this can be used the spread area. This is also one of the technique for reducing the surface area, and also in the small area we can provide by the top of the just like the tents can be provided to reduce the evaporation, the direct sunlight which is not allowed in the top of the ponds and lakes. So that is the small areas can be only possible, but in the area is very big, you can use some of the techniques like lightweight spread over the entire lakes. It can be also some of the techniques to use the to reduce the radiation effect in the temperature, and direct sunlight which is also can be reduce the evaporation by applying the lightweight bricks and metals. And that is the one of the technique can be used for the reducing the evaporation. Next, application of the evaporations as evaporation is one of the most important process of manufacturing industries. It can be used for preparation of liquid extracts, solid extracts, dye extracts, and it can be concentration of the blood plasma and serum. It can also be used for the manufacturing of the drugs containing the antibiotics, can be also enzymes and many other substances. Purification of vitamins. Of course, these are all can be used in the chemical purposes and using. But in the evaporation can be used in different type of the sources is there for whatever the evaporation. The manufacturing chemical oils is also can be used for the techniques used for the purifications, can be separation of the oils can be also used for the evaporation techniques can be used. But also in the as per the hydraulic concern, subject concern, the evaporation in the generally the ponds and lakes and rivers, what are the evaporation can be calculated, this one, and what is the use of the evaporation for reducing the evaporation, and estimation of evaporation means whenever you have to construct on certain area to propose for the hydraulic structures, whether it is small or big, can be constructed like dams, reservoirs, spillways, culverts, whatever it is. Any of the hydraulic structure when you have to construct, you have to know the such type of the data. So just like not only the precipitation data and the hydraulic data, and also you have to know the type of the evaporation losses can be on certain area can be used. Not only that, it can be used for the irrigation purposes, but according to the evaporation process, the plants growing of the plants, how much water is required on this entire growth of the some crop it can be also estimated by using the evaporation as well as the evapotranspiration. The techniques can be used for the evaporation techniques. So evaporation and transpiration, evapotranspiration of these techniques, and another video is also done by me. So this is the anybody wants, you can see in the website. So that is the evaporation empirical formulas, and also some of the methods can be used for how to reduce the evaporation. Techniques can be applied for reducing the evaporation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.